Welcome to Context Window, your weekly deep dive into the bleeding edge of AI coding tools. We're here to rigorously dissect the latest from Claude Code, Copilot, Gemini, and more, providing you with the unbiased context behind the hype. Join us as we explore the real-world impact and complex narratives shaping this rapidly evolving space. Let's get into it.
Okay, so imagine a world where every single AI agent you build, whether it's for customer service or complex data analysis, suddenly operates on a universal standard. No more rewriting everything from scratch just because you switched frameworks.
And on top of that, imagine that every single change that agent makes, every new skill it learns, every shift in its digital personality is tracked, version-controlled, and auditable, just like code. That's the audacious promise of GitAgent.
It's being called the Docker for AI agents, and if it works, it could fundamentally reshape how we develop and supervise autonomous systems. But can it really deliver on that write once, run anywhere dream for something as complex as AI behavior? AI Tooling Radar. All right, let's kick off with our AI Tooling Radar, a rapid-fire scan of the most important updates in the AI coding world. Expert, what's buzzing first?
First up, OpenAI is on a shopping spree again. They've just acquired Astral, the company behind popular Python developer tools like Rough and Uve. This is their third acquisition in recent months, and the Astral team is joining OpenAI's Codex group.
That's a bold move. So they're not just buying a company, they're buying their way deeper into the Python developer ecosystem.
Exactly. The report suggests OpenAI isn't content with just code generation. They want to be part of the entire software development lifecycle: planning, modification, maintenance. By snapping up a team specializing in high-performance tools written in Rust, they're fortifying Codex, pushing it from a helper to a core part of the stack. It's a strategic play to lock developers into their ecosystem.
Shifting gears, Google's Gemini API just got a brain boost for agentic workflows. What's new there?
Google has significantly enhanced the Gemini API, letting developers combine built-in tools like Google Search and Google Maps grounding with their own custom functions in a single API call. This means more complex, multi-step reasoning with reduced latency. They've also extended Maps grounding to the Gemini 3 model family.
So Google is leveraging its biggest asset, its massive trove of real-world data, to make its agents smarter and more contextually aware.
Absolutely. This update is a direct response to developer requests for easier orchestration of complex agentic workflows. It's a powerful feature for applications needing a deep understanding of the physical world, moving Gemini agents beyond simple chat towards more complex, useful tasks. Google is really playing to its strengths here.
Next up, some drama from the code editor space. Cursor's new Composer 2 model is causing a stir. What's the scoop?
Oh, this one's juicy. Cursor launched Composer 2, touting frontier-level coding intelligence. But the developer community quickly discovered it was built on an open-source model from a Chinese startup. Cursor initially omitted this detail.
Wait, they just didn't mention it? That feels like a significant oversight.
Omission is the polite word. While building on open source is common, Cursor's failure to disclose it, especially given their high valuation, sparked a huge backlash. It raises questions about transparency and where innovation truly comes from. It's a reminder that clear attribution is crucial for trust in this ecosystem.
Finally, what's happening with GitHub Copilot student plan? I heard there were some changes.
Indeed, GitHub has downgraded its free Copilot plan for students, removing access to some premium models. They cite sustainable long-term access as the reason, but students are understandably furious.
So essentially, they got students hooked on the good stuff, and now they're pulling the rug out, pushing them towards paid plans for the best models.
While providing free access to premium models is expensive, the messaging has left a sour taste. It's a stark reminder that in the world of AI, free often comes with an expiration date. The fragmentation problem. Why do we need a Docker for agents?
Okay, that was a whirlwind. Now let's dive into the core problem GitAgent is trying to solve. The report paints a pretty stark picture of the AI agent development world, calling it fractured and balkanized. What exactly does that mean for a developer?
It means if you're building an AI agent today, you're immediately faced with a critical, almost binding decision: which framework to use. You've got your LangChain and AutoGen, and each one is a distinct ecosystem. They have their own rules, their own philosophies, their own technical implementations. It's not just a preference, it's a fundamental commitment to a way of thinking about how an agent should be constructed.
So if I start building an agent in LangChain, I'm essentially locked into that world. I can't just easily switch if another framework offers a better feature or performance.
Precisely. That's the pain of lock-in. Each framework has its proprietary methods for defining an agent's logic, how it remembers information, how it interacts with external tools. There's no common standard. The report gives a great example. An agent built in LangChain, which uses chains or sequences of operations, cannot be easily ported to AutoGen, which is built around multi-agent conversations. Moving between them isn't just a tweak, it's often described as a near-total rewrite of the core codebase.
A near total rewrite. That sounds like a nightmare for any engineering team. It reminds of the early days of personal computing, where software for one operating system was completely incompatible with another. You had to choose your side and stick with it.
Exactly that analogy. And for enterprises, this isn't just an inconvenience, it's a major hurdle. Companies might build a proof of concept on one platform only to find themselves stuck when they want to switch to a different model for cost, performance, or new capabilities. This inability to easily migrate leads to significant technical debt and stifles innovation. The complexity of integrating and maintaining agents across these different ecosystems is a recurring pain point and a real risk for businesses investing in this technology.
So we've got this fractured landscape: proprietary methods, high switching costs, and technical debt for businesses. It sounds like a perfect storm for inefficiency and stagnation in the agent development space. This is where GitAgent steps in, aiming to be the Docker for AI agents.
That's the grand ambition. The deconstruction problem. How does it actually work?
So GitAgent promises a universal format. How does it actually propose to solve this problem of fragmentation? What does this Docker for AI agents analogy really mean in practice?
The core idea, like Docker, is to decouple the definition of an agent from the environment in which it runs. With Docker, you package your application and all its dependencies into a standardized container, and that container runs anywhere Docker is installed. GitAgent aims to do the same for AI agents, create a standardized, framework-agnostic way to define an agent's identity, its skills, and its rules.
So instead of being tied to LangChain's specific way of doing things or AutoGen's, I define my agent in this universal GitAgent format.
Precisely. It treats the agent itself as a structured definition within a Git repository. This definition contains a set of key elements that govern the agent's behavior, and critically, these elements are human-readable and version controllable.
Fascinating. How does it define an agent in this universal format?
The idea is to use a structured, human-readable, and version-controllable definition. This would encompass the agent's identity, its capabilities, and its operational rules, moving away from proprietary framework-specific implementations.
So I define my agent once in this universal format, but then how does it actually run in, say, a LangChain environment?
The promise is that once defined in this universal format, GitAgent would provide a mechanism to translate that definition into the specific format required by your target framework, whether that's LangChain or AutoGen. The goal is to map the agent's universal logic into the framework-specific implementation.
So it's truly write once, export anywhere? That sounds almost too good to be true, expert.
That's the cornerstone of their promise.
The universal format versus the real world.
You hit on my exact thought. It sounds too good to be true. While the concept of a universal format is incredibly appealing, is it truly possible to create a perfect, lossless abstraction for systems that are fundamentally so different?
That's the critical question, and it's where skepticism rightfully enters the conversation. LangChain, as we discussed, is built on chains, often deterministic, sequential workflows. AutoGen, conversely, is designed for emergent, conversational collaboration between multiple agents. These aren't just different implementations, they're different paradigms for how AI agents should operate.
So how does one universal definition perfectly translate into both a linear chain and a dynamic multi-agent conversation without losing some of the unique strengths of each?
The specifics of how that complex translation happens are crucial. A significant pitfall is that in the quest for universality, you might only cater to the lowest common denominator of agent capabilities. You could lose the unique, powerful features that make each individual framework attractive in the first place. It's a tough balancing act.
And beyond the technical challenges, there's the ecosystem buy-in problem. Docker became a standard because it had broad industry adoption. Will the major players, Anthropic, Microsoft with AutoGen, the LangChain community, OpenAI, embrace an external standard like GitAgent?
That's the huge hurdle. These companies have a vested interest in building out their own highly optimized ecosystems to attract and retain developers. They might view a universal format as a threat to their competitive advantage, preferring to keep developers locked into their specific platforms. It's a standards war, and getting all the generals to agree on a common flag is notoriously difficult.
Yet GitAgent isn't appearing in a vacuum. The report points out a broader trend towards standardization in the AI industry. Where does GitAgent fit into that larger picture?
It's part of a growing recognition that for the AI agent ecosystem to mature, we need interoperability. We're seeing this at the tool use layer with the Model Context Protocol, or MCP, which is an open standard for how AI models can securely connect and interact with external tools and data sources. The report describes MCP as a USB-C port for AI.
A USB-C port for AI. I like that. So MCP standardizes the connection to the outside world, and GitAgent is trying to standardize the agent itself.
Exactly. MCP addresses the interface to tools. GitAgent addresses the definition of the agent. Together, these efforts suggest a maturing ecosystem where standards are becoming increasingly necessary for long-term growth and stability. GitAgent is attempting to solve a more fundamental problem at the agent definition layer.
Git as a supervision layer.
Expert, of all the innovative aspects of GitAgent, the one that truly jumped out at me from the report was its use of Git not just for storage, but as a primary supervision layer. That sounds potentially transformative. What does it mean?
This is, in my opinion, one of the most fascinating and impactful aspects. A major challenge with autonomous agents is the black box problem. It's incredibly difficult to understand how an agent's behavior changes and evolves over time. This lack of transparency is a huge barrier for enterprises, especially in regulated industries where auditability is non-negotiable.
So GitAgent's solution is to treat agent evolution like code evolution?
Precisely. Its innovative solution is to treat any change to an agent's internal state, whether it learns a new skill, updates its memory, or even modifies its core personality, as a code change. The system can be configured to automatically track these changes within Git.
Wait, an agent makes a change and it's tracked in Git? That brings a familiar software development workflow directly into agent governance.
Exactly. This Git native supervision provides a powerful mechanism for human-in-the-loop governance. A human reviewer can inspect the Git diff of an agent's proposed changes, just as they would review a colleague's code. They can see exactly what the agent has learned or how its personality has shifted.
So, if an agent starts acting strangely or drifting from its intended purpose, I could actually see the Git diff of its defined rules and say, nope, that's not what you're supposed to be doing.
That's the power of it. If the changes are beneficial, they're approved and merged. If the agent exhibits undesirable behavior, the reviewer can reject the proposed changes, or even use git revert to roll the agent back to a previous stable state. This transforms the opaque, often unpredictable process of agent evolution into a version-controlled, auditable, and collaborative process.
That's a game changer. The audit trail alone sounds invaluable for enterprises dealing with compliance and risk management.
It really is. The Git history, the commit logs, becomes a complete and immutable record of the agent's entire lifecycle, how it changed, who approved those changes, and why. This is powerful for debugging, compliance, and building trust in autonomous systems. By leveraging tools and practices developers already use, GitAgent has the potential to make AI agent management transparent, secure, and reliable.
This could absolutely be a game changer for enterprises wary of the risks of autonomous agents.
That's a game changer. The audit trail alone sounds invaluable for enterprises dealing with compliance and risk management.
It really is. The Git history, the commit logs, becomes a complete and immutable record of the agent's entire lifecycle, how it changed, who approved those changes, and why. This is powerful for debugging, compliance, and building trust in autonomous systems. By leveraging tools and practices developers already use, GitAgent has the potential to make AI agent management transparent, secure, and reliable. This could absolutely be a game changer for enterprises wary of the risks of autonomous agents.
That's great. Expert, this has been an incredibly insightful look into GitAgent. If listeners take away 3 key things, what should they be?
First, the current AI agent development landscape is highly fragmented, leading to significant lock-in and technical debt, which is a major hurdle for enterprise adoption.
And GitAgent's proposed solution is a universal, framework-agnostic format, allowing developers to define agents once and export them to various popular frameworks, aiming for that write once, run anywhere ideal.
Absolutely. But the crucial third point is its innovative use of Git as a supervision layer. This provides human-in-the-loop governance, treating agent evolution as code changes, creating an auditable, version-controlled history of an agent's behavior.
That's so. Looking ahead, 2 questions for our listeners to ponder. First, how critical is broad industry buy-in for a tool like GitAgent to truly overcome the entrenched interest of major framework developers?
And second, can a universal abstraction truly capture the nuanced and often conflicting paradigms of different agentic frameworks without compromising their unique strengths? The success of GitAgent will hinge on answers to both of those.
That wraps up another episode of Context Window. Join us next time as we continue navigating the complexities of AI coding tools.
In the world of AI, context is king.